arm moves in and feeds the sock to a set of rollers. A blade pushes the sock down while the rollers turn the sock right side out. A vacuum chute fires the sock into a bin. Then it's on to the rotary dyeing machine. He loads 1,800 pairs or more depending on the size of the dyeing machine. The socks toss around in a bath of dyes, chemicals, and softeners. For athletic socks, they add antimicrobial treatment to the mix. It will help prevent fungus or bacteria that cause foot odor. Now they slide the sock onto a foot form made of polished aluminum that won't cause snags. The aluminum leg forms stretch the socks to the prescribed size as they travel down a conveyor belt into a boarding machine. The boarding machine is like a gigantic iron, and the heat seals the stretch in the nylon so the sock stays that size. Once out, a robotic arm grips the sock and pulls it off the aluminum form. It's called a stripper. Then, an automated rack with protruding pins collects the socks. The worker removes them a bunch at a time, and the socks are ready for packaging. And then, all you have to do is pull up your socks. A hypodermic needle is the proper term for a syringe and needle. It's used to draw blood or inject medication. This indispensable tool was invented back in 1853, but it wasn't until 1954 that mass-produced disposable syringes came on the market, developed for the vast immunization campaign against polio. A syringe may make you cringe, but the treatment it delivers could be a lifesaver. To make a hypodermic needle, they start with a flat strip of stainless steel. A milling machine rolls it into a tube shape. A laser welds the seams together. But what makes the steel stiff enough to use is something called cold work, in which they press the tubing through a die several times. This also slims the tube dramatically, so now you have a thinner, tougher tube. It takes about a couple of days to turn the stainless steel strip into a tube with needle potential. But it will have to be sharp to perform, and the next steps will focus on getting the steel tube to a point where it's more than just a blunt object. An electrically powered blade scores the walls of the tubes as rubber pads bear down and roll. This rolling causes the tubes to finally break at the score line. The tubes are being cut down to size, about 5 centimeters long. The tubes fall into a bin, a tangled mess. The bin, driven by air pressure, agitates, and this shaking motion straightens them out. An operator bundles them together with a plastic band, but removes a few to check the specs. This micrometer uses laser light to measure the outside diameter. The tube is supposed to be 2 millimeters, and it's right on. Next, a mechanically driven drum rolls super adhesive tape onto the tubes. The tape will hold the tubes in place as more work is done on them. They razor cut 12 centimeter strips of the tape tubes so that there are about 100 tubes per strip. Then they spray aluminum oxide on the ends of the tubes. This roughs them up so that the surface will be easier to work with. Now they place the strips of tubes into the grinding fixture, and then they snap it shut. Coolant flushes over the tube tips as the fixture moves across a grinding wheel. The wheel grinds through the tops of the tubes, shaping them into a rough point. This is only the first grind, so it's not yet needle sharp. Now the fixture rolls and rotates the tubes. Then it's back to the grind. The angle of the wheel is changed so that it sands the sides of the tubes. These two secondary grinds sharpen the tubes into a finer point. This is how they looked before grinding, and this is after, with their sharp needle tips. Now it's time for the big inspection. She pushes the ends of the needles with the back of her tweezers to make sure they're even, and then pulls out a needle for sampling. She measures the length of the grind. It should be a few millimeters long. Next, she sizes up the needle's outside diameter with a micrometer. Holding the needle between posts, it measures the space between them. Then she checks the inside diameter by inserting a plug gauge into the tube. Now she inspects a whole bundle of needles for irregularities or burrs. Using tweezers, she removes one for a close-up look under the microscope. Once they pass inspection, it's on to the big wheel or the automated assembly machine. Brass and nickel-plated fittings called hubs drop onto pins on the wheel. Then needles fall into the hubs. Metal fingers align them so they fit together precisely. The hub is the piece that will connect the needle to the syringe. Automated crimpers press the needle into the hub. Sheer friction bonds them. Now, two metal pads on the same wheel position the needle. A plastic sleeve drops down, encasing the pointed tip. Finally, a robotic arm lifts the needle off the wheel and drops it into a bin. The needles are now ready for you, but are you ready for them? If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at www.howitismade.net.